For the past 2 or 3 weeks, I've been working on a new design for the robot leg ankle. And what I've come up with, so what I'm trying to solve here is being able to go forward and backward and side to side all at the same time, so you get a full range of motion in your ankle. So that's going to greatly help while dynamically balancing the robot's weight as it walks, as it takes a step, so we won't have to do something silly like give it massive feet or something like that, overcompensate that way. So what I've come up with is, you got this linear actuator up top, upside down, as opposed to the bottom one. The bottom one is going to control front and back motion, and the top one, side to side motion. What we've got here is just this little teeter-totter, if you will, little fulcrum apparatus, and as linear actuator comes up and down, it pivots on this point right here. So two arms, one on the left, one on the right, that will teeter-totter. So connected to each side is this control arm. Now this actually, it's just a big bolt, right? But acting as a control arm, comes down and just have this aluminum block in here for a spacer right now, but it connects to this universal joint, so it can rotate 45 degrees in all directions. And over on the ankle, allowing me to go front and back and side to side, I've got a joint here, or a pivot here, and then a pivot right in here through this block. So that's going to give me all the different degrees of motion as it walks. So I'm just going to hit the power on this guy. I've got it hardwired to a power supply just so we can see some action, see what it does. So first we'll go side to side. So it's just going to collapse in one direction. As it, it would shift its weight before it steps forward. So we're going to shift all of the weight of the machine, of the robot, to one side. It's outside, and then it'll be able to take its step forward once it's balancing on the opposite side. So obviously what's lacking over here is another one of these bolts, another one of these control arms that will give increased stability and balance. But it's pretty sturdy. There's definitely some structural things that need to get fixed. The outside is aluminum, and this bracket here is mild steel. I think everything's gonna basically get upgraded to mild steel. It's not all that heavy. It's only 1/8 of an inch thick. But just in terms of, because you got a lot of movement, you got a lot of different dynamics going on. So I think the beefier steel will do better. So as I sway to one side here, give it a little more angle, get a decent angle there, and then I'm just going to manually pull the power on the top actuator and switch it to the bottom and demonstrate its range of motion. So it can go to the side, and then it will also, let me just clip this on, very difficult one-handed. So it'll be able to go to the side, and then as it's to the side, it'll also be able to go forward and backwards. Again, thanks to that U-joint and the various points of motion that we have down there. So now it's kind of, if you look from the top here, it's kind of at a skewed angle. It's off to the side, and then it's back a little bit. So should be able to balance the weight nicely. We'll see. That's my update.